Hey everyone, today we're going to go through the PT6 Hartzell steel propeller combination and describe how this system works. This is a full reversing, full feathering propeller. I'm going to go through each individual component and how this system operates. On the top of the engine we have our constant speed unit, and the constant speed unit can be manipulated by the pilot by pulling on the prop control lever. Pulling the prop control lever back will reduce the engine RPM, and if they pull it far enough, it will feather. Down on this side, we have our tachometer generator, which gives the indication in the cockpit of the RPM of the propeller. This piece here is the reverse linkage. This is a reverse reset linkage, which resets the fuel topping governor to limit the maximum RPM that the engine can drive the propeller in reverse. Back to the governor again. The governor has a feather stop and it has a high RPM stop. When you release it, it goes to the high RPM stop, and when you pull it, it goes to the feather stop. As we come down on this side, we have the beta valve. The beta valve's job is to hydraulically lock the oil into the hub of the propeller when the beta ring is pulled forward. I'll show you the beta ring in a moment. So it's a balancing point. Its position is a balancing point between the reverse linkage, which I can see I'm pulling back on, and the position of the beta ring. And the beta ring is kind of the feedback. It's the beta feedback ring, and it's giving the blade position. It's kind of letting the beta valve know what blade position it's in. And it rides in that groove with a carbon brush. And that carbon brush, as you can see in there, is completely wore out. This is a unit here for overspeed. So that's the overspeed governor, and the little solenoid there is the test for it. That's when we go to test it. Coming around to this side of the engine, we can see our propeller. We can see the beta nuts, sometimes known as the no-no nuts. Not supposed to adjust those necessarily on some of the older aircraft, and on the newer aircraft, that is the method for adjusting the prime blade. When the piston is in normal operation, it comes out of feather, and once it comes out of feather, it'll pull the beta ring ahead slightly. When it does, the hydraulic fluid, or the boosted oil pressure, will be locked into the propeller hub, and that will stop the propeller at the secondary low pitch stop, or the hydraulic stop, or sometimes known as prime blade. So the beta ring, when it moves ahead, will pull the beta valve forward. When the beta valve moves forward, it locks the oil. If it moves forward too far, it will actually dump oil from the propeller back into the engine and cause the engine to go, or the propeller to go towards a course pitch. So it's a balancing act between the feedback ring and the reversing linkage to where the beta valve sits. Here we go. We have everything connected, and we're going to give it a go. So here's normal operation. There would be cruise kind of power coming up to just contact with the beta nuts, and as we pull the beta ring ahead, the beta valve pulled ahead right there. And that would have locked the hydraulic fluid into the propeller, and the blades would be stuck at prime blade. The pilot then selects more reverse, pulling the beta valve in. The beta ring will have to come ahead, and as the pilot consciously selects reverse, they can select anywhere from the prime blade, which is usually about 11 degrees, all the way back to full reverse, which is probably around -11 degrees. And that's how this unit works. So the beta valve is in control of the propeller anytime the constant speed unit is below governing RPM, or governing range. Thank you, and have a great day.